All right, this is part 3 of our exploration of the extinction crisis that we're in today. You might remember this slide from our exploration of deep time. This is illustrating the timing of the 5 great mass extinction events that have happened in Earth's history. These can be defined in many ways, but a commonly accepted one is that a mass extinction is when you get significantly more extinctions than the overall background extinction rate. So if the average extinction rate is about 2 to 5 families per year, and then there's some event that causes something like 20 different families to go extinct, then you're talking about a mass extinction. And if you're trying to remember what families are, remember that we organize life in terms of a taxonomic hierarchy. We've got species, and then species are grouped together with similar species under the umbrella of genus, and then different genera are grouped together under families. So for example, all the cats of the world are in the same family. All the dogs of the world are in a different family. Okay. We're now in a phase of Earth's history where we're in another extinction crisis. In fact, the rate of species lost on the planet is now equal to, and in some cases surpassing, the rate at which we've lost species during those 5 mass extinction events that we just talked about. The current extinction rate of species on the planet is about 1,000 times higher than the background rate before humans started spreading out across the planet. We are losing, it's calculated we're losing dozens of species every day, and it's unfortunately estimated that we may lose as much as 30 to 50% of species by the end of this century. I've got some updated stats for you on that a little bit later. Now, remember what are some of the causes of those mass extinction events in the past? We've seen examples of changing in the continental, or the arrangements of the continents on the planet, and the triggering of ice ages. We've seen the impacts of comets or asteroids on the Earth causing major disruptions. And then we've got some of those mass extinction events from Earth's history that we just don't know for sure yet what caused them. But we know what's causing the current extinction event, and that's us. The overwhelming evidence is that humans are to blame. And yeah, just using this graphic here talking about elephant exploitation, the harvesting of elephant ivory is quite likely to lead to the extinction of the species this century if we don't stop harvesting ivory for ornamental use. Now, what species tend to go extinct? Not all species are vulnerable to extinction, so what makes one species more vulnerable than another? Well, species that are naturally rare to begin with, they have limited distributions, or there's just very few of them, and so they're more likely to go extinct if there's something impacting their environment. Species that have very low dispersal ability are vulnerable. So if you have a rare species of plant that can't get out of the way of a bulldozer and development, then it's potentially going to go extinct unless there's some sort of rescue. Species that are highly specialized, and here I'll point to the freshwater mussels of the southeast. They have that very specific relationship with different types of fishes, such that usually one mussel species can only parasitize 1 or 2 fishes to have its larvae dispersed in this river or stream. So if you lose the fish, you're going to lose the mussel as well. And we've got many cases of that happening in the southeast today. Top predators tend to be very vulnerable because they're very sensitive to any changes in the availability of their prey, and their prey, of course, are very sensitive to anything that's affecting plant availability or species that the prey are dependent on. Top predators also tend to be singled out because they, at least in the past and as well as some current ecosystems, we compete with them for food. In the past, we were killing top predators because they were also hunting the prey species we like to eat. And then a final reason why some species are more prone to extinction than others is that they have slow reproduction rates. For larger mammals, for example, it can take many, many months, sometimes over a year, to get an offspring such that it's old enough that it can be on its own. When you have species with these slow reproductive rates, it takes them a long time to recover when their populations have been reduced. We talked earlier about the fact that islands tend to be very vulnerable to extinctions, much more so than on the mainland. Check out this table where we compare mainland extinction numbers and island extinction numbers. And then over here you can see approximate numbers of species. And if you look at all over the entire planet, there's been, at the time of this graphic was made, which was probably about 10 or 15 years ago, there had been about 30 mammals that had gone extinct on the continents, on mainland. But on islands, it's more like 51 species that have gone extinct. We see similar disproportionate impacts on island fauna for birds and reptiles. And then we also see similar proportions with invertebrates. These numbers look equal, but when you consider the fact that islands are a very small amount of land mass relative to the continents, these two numbers being somewhat equal show that actually islands are very vulnerable to extinctions. And I would say the same for all of these numbers, like the vascular plants. One exception, of course, are the fishes. Freshwater fishes don't make it out to islands very easily or often, sometimes not ever at all. And so there have been very few fish populations going extinct on islands. Now you've seen this slide before. This is from the Stockholm Resilience Center. This is our dashboard, if you will, for looking at how humanity is living on the planet. There's 9 different wedges here to the circle. These are the 9 different indicators of how well we're doing when it comes to living sustainably on the planet. And these dotted lines indicate different levels of risk. So here we see crossing the threshold of from the safe zone at the interior of the circle. This is the safe zone I'm circling here. You cross this dark dotted line and you're in a zone of uncertainty. You're not sure how the ecosystems or these other systems are going to behave. You cross this outer dotted line that you see over here, and you're crossing into very vulnerable territory where we simply don't know all of the consequences that we're going to have, the negative consequences that we're going to have with the depletion of that resource or the degradation of that process on the planet. And of course, the reason that we're talking about this again is because this has a lot to do with extinction. This wedge up here that I'm circling, biosphere integrity, if you were to look up in the liner notes, if you will, for this figure, these values here are about biodiversity. Especially this one right here is why I'm drawing our attention to this. This is about the loss of biodiversity and the loss of all the good things that biodiversity can bring us. That's what's happening here with this E/MSY. As you can see, we are well past this critical threshold where we are in the orange zone here, a zone of high risk and high uncertainty about what the future of humanity will be facing, given that we've lost so many species already and even more species are queued up to go extinct. We can group the causes of extinction into 7 categories. And several years ago, Edward O. Wilson, an Alabama native and one of the greatest living scientists today, at least here we are in 2020, he coined the mnemonic of HIPPO to help remember these 5 of these categories. Since that time, we've added climate change as a driver of extinction. I'm going to go over some slides that exemplify these 6 in the next few minutes, but make sure that you understand what these 6 are and their relative order, because they're stacked in the order of past extinctions, with habitat loss and alteration having caused the most extinctions so far, and then followed by non-native invasive species. These other ones are kind of a wash, and climate change is the new kid on the block. That will be obviously causing a lot of extinctions in the near future. We'll be talking plenty about that soon. So habitat loss and alteration, habitat degradation or alteration, these are major causes of extinction in the worldwide. You and I participate in that every day. The built environment that we live in, the urbanized environment, of course, has replaced a wild natural ecosystem. But actually, urban landscapes have relatively small footprints on the planet. Much bigger is agriculture. Every time we're eating cultivated foods, we're eating food from lands that have been heavily altered to favor just one or maybe a couple of species at the expense of many thousands to sometimes millions of species in the ecosystem that was replaced by agriculture. So this has been, the expansion of agriculture has by far been the biggest cause for the loss of species on our planet so far. The second biggest threat is non-native invasive species. Of course, we do a lab in this course focusing on English ivy and the impact it's having on our ecoscape. But the English ivy is not likely to drive any species around here to extinction, but other non-native invasive species have caused many extinctions. You're looking at one of the ones I like to pick on a lot, which is the house cat. Cats are incredibly efficient predators, and in the wild they do significant damage to wild populations. The cats have specifically been the cause of the extinctions of several species around the world. It's not just mammals, though. Sometimes it's reptiles. This is the brown tree snake that's found in Guam. It wiped out many species of birds on that island, and we're still trying to get rid of that snake on the island. And then, of course, plants are also a huge a number of our non-native invasive species. Obviously, you're learning about English ivy in our labs. Kudzu, you've probably heard of before. This is a picture of kudzu. There are thousands and thousands and thousands of non-native invasive plants that are spreading around the world and causing damage in the ecosystems into which they invade. So the third highest ranked cause of extinction has to do with human population growth. And I want to be clear here, it's not the number of people on the planet per se. We could probably sustain about 7 to 9 billion people on the planet if we were to live more carefully and more balanced with nature. It's more the way that we use our resources. We use a huge proportion of the resources relative to what's available in nature, and we're not very efficient with it. We're kind of sloppy. There's a lot of wasted land, wasted nutrients, minerals, and so forth and so on. And all of that causes a lot of destruction in the environment, and that leads some species to extinction. Pollution is one of the impacts, of course, that we humans create through the industrialization of the supply chains that sustain us in the modern world. The pollution varies from these sort of graphic pictures you see here to things that are more invisible, like organic compounds that get into our rivers and streams and affect fishes, and in some cases affect us. I mean, we have some of the highest cancer rates in the world are here in the U.S. It's thought in part due to the exposure to toxins in the environment. Other types of invisible pollutions include carbon dioxide, which we'll be talking about in just a couple minutes. This is a rather nasty slide. This is to illustrate the O in hippo, and that's overexploitation. This is the over-harvesting of species. It can be animals, like you see these graphic images, but it can also be plants. Modern humans are very effective in our ability to capture and kill species of animals or harvest plants on the planet. And in these instances, we are driving some species to extinction. Elephants, like I mentioned earlier, are quite possibly could go extinct this century if we don't stop the illegal ivory trade. Fisheries, as you see on the right, a fishery, of course, refers to a species of fish in a geographic area that sustains jobs in the harvesting of that species. It doesn't have to be fish. It can be crabs or squid or something like that. That's what a fishery is. And there are fisheries around the world that have collapsed because of just the overharvest. So we're just really good with building large boats with huge nets, and we're out there 24/7, 365, and it's really hard for fishes and other animals to compete with that. And then the final cause of extinction is climate change. But we are absolutely going to see more of that this century. And we're going to be spending a lot of time on climate change here, so I'm not going to spend too much time on this right now. Just suffice it to say that we are changing the world's ecosystems in some very fundamental ways, and it's going to be very difficult for a lot of species to keep up, as exemplified by the picture of the polar bears on an iceberg, which accompanies pretty much any mention of climate change these days. So how bad is the extinction crisis? Well, just this last year in 2019, a report came out from the United Nations that estimated that by the end of this century, 1 million species could be extinct if we continue on with the way that we're living on the planet, the way that we're using resources on the planet. And that's 1 million species, that's plants and animals alike. So that is a staggeringly large number. The impacts that will have on ecosystems and the ecosystem services that they provide are at this point incomprehensible. This was a big warning to us all. Okay, next I want to move on to the question about why extinction and endangerment is so high in Alabama. Why are we number 2 for extinct species and number 4 for at-risk species? There are several different reasons. One has to do with simply because we've got a lot of species. So when passenger pigeons went extinct in the southeast, we of course had passenger pigeons because we have many species in our state, and that counts as one of our extinctions. So just by having more species means that when there are extinctions, we're going to lose more. Alabama also has done some major alterations to its rivers, and as you know by now, our rivers and streams harbor the majority of the biodiversity that we have in the state, and so consequently, the alteration of our rivers and streams have led to the extinction of many species. Go back to that slide where I listed out what Alabama species have gone extinct, and you'll see that the great majority of them are aquatic freshwater species. Another reason why we've lost a lot of species and will continue to lose species unless we change is that we have very lax environmental protections in the state. We're a state whose lawmakers actually pride themselves in giving a lot of leeway to industries to pollute and not having a lot in the way of environmental protection, which is unfortunate because you can have good environmental protection and a healthy, strong economy. Just look at California. Finally, one of the most important reasons why we've had so many species lost in Alabama is just all those general reasons that we covered before, the hippo reasons. Those have all been very pervasive in Alabama. So we've got to acknowledge those as a cause for why we've lost so many species as well. So sometimes students ask me, they say, well, won't species adapt to living with humans? Won't they get used to it? And the fact is that some species have adapted and some species are adapting, but those tend to be very, what we say, generalist species. They're good at living in a variety of habitats. Instead, there are many species that just will never be able to live in an urbanized area or an agricultural area. And those are the ones that are at risk of extinction. We also have to acknowledge that it does take tens of thousands to maybe hundreds of thousands of years for species to do major adaptations in order to cope with environmental change. Now keep in mind that those mutations that lead to evolutionary change are all random. It's not like species can conjure up some mutations that will help them out in the age of humanity. Instead, they're just subject to random mutations, and maybe they help, and most of the time they don't. So I want to wrap it up here with checking in on the logic of conservation, why we should protect species for our own self-interest. We're in a period of high extinction rates. That's something completely under our control, and we can stop. Extinctions, of course, damage our ecosystems. They remove the species that make our ecosystems work. Damaged ecosystems are going to provide fewer of the ecosystem services that we depend on. So if we're going to save, or when we save biodiversity, we're also saving ourselves at the same time. So taking care of species and ecosystems and keeping them around isn't just something to do because it's morally correct or out of compassion. It's actually selfish. It's in our own self-interests. It's that simple. We should protect species and ecosystems. Okay, that's the end of our third installment in looking at extinction. We've got one more to go, and then we'll be done with this unit.